A model for an object's motion is that its acceleration dv over dt is proportional to v to the power 1.5, where v is its velocity measured in meters per second. Question A. Write down differential equation based on a model. What does it mean that something is proportional? It means directly proportional. It means that dv over dt is equal to some constant of proportionality and multiplied by v to the power 1.5. And it's the required differential equation. Question B. Use the model to find an expression for the velocity of the object after t seconds. It means what? That we should solve this differential equation and we should get what? V as a function of t as a result. And how to solve this differential equation? By separating variables, everything with v to the left, with t to the right, so it becomes 1 over v to the power 1.5 dv is equal to k dt. Then integral, and how to integrate the left hand side? It's what? V to the power of negative 1.5 to be in the numerator, and just applying the rule for the integral of x to the power 1, and integral it's what? X to n plus 1, and divided by the obtained power n plus 1. So here negative 1.5 plus 1 is what? Negative 0.5, and divided by negative 0.5, so it becomes v to negative 0.5 divided by negative 0.5 is equal to, it's just integral of 1, and it's just t and multiplied by this constant, so it's just kt and plus some constant of integration. And we can multiply by this negative 0.5. We can multiply each term on both sides to get v to negative 0.5 is, it's some constant which also should be found, and multiplied by negative 0.5, it's just another constant to be found. So let just rename it, let it be a, for example, t, and plus constant multiplied by constant, it's just another constant. Definitely this can be rewritten as 1 over v to the power of 0.5, and 0.5 is what? To the power of a half, and the half is what? Just square root. So it can be rewritten as v to the power of square root of v or something like that. But since we need expression for velocity, so v is equal to something, how to get rid of this power? We can raise both sides to such power so that it becomes v to the power 1. It's like 2 to the power 3, and to the power 5 it's what? 2 to the power 3 times 5. And the idea is that you should choose this to be some value so that you get 1 finally, and it's should be what? Negative 2. Negative 2. Hence, it becomes v to the power of 1 plus 1, just v is equal to, and something to negative 1, it is squared in the denominator. So let's rewrite at plus b to negative 1, or 1 over at plus b squared. And to find a and b, you can see that it is given that initially velocity is 4, so v at 0 is 4, and acceleration, and what is acceleration? It's derivative of v of this function at t is 0 is negative 3. You can see that when t is 0 it disappears, so we can find b now. So substituting this, we get that 4 is equal to 1. Definitely to calculate it's more useful to use this. So it's what? 0 plus b, which is b squared, and cross multiplication, or it's a proportion, you can move factors along diagonal. So anyway, b squared is 1 over 4, or multiply both sides by b squared and then divide by 4, you get that b is a half. so b is found. And to find a, we should use definitely what this, and we need derivative. I can rewrite, so v is at plus a half to the power of -2, and definitely to find derivative, if you use this, it should be used what quotient rule. U it's 1 and v it's this denominator, or if it is rewritten or given or represented like this, it's just chain rule. And how it works, something, notice that it's something to the power, and the chain rule says that it becomes, you apply the same rule as it would be x to the power of -2, and you keep this instead of x, so it becomes -2 and this to the power of -3 and multiplied by this derivative. Or quotient rule for this. So dv over dt becomes -2 at plus a half to the power of -3, and at plus a half derivative, it's derivative over sum, it's sum of derivatives, derivatives over half, it's 0, and at derivative it's just a, and it's what, -2a over at plus a half cubed. And derivative at 0 is -3, so -3 is what, -2a 0 a half cubed, and it's what, 1 over 8, so it becomes -2a times 8. So a is what, 3 over 16, and it becomes v is, we can use this, 1 over 3t over 16 plus b squared plus a half squared. Let's check whether we can get the same result using quotient rule for derivative. So data booklet says that uv derivative it's v squared u derivative v minus uv derivative, and u is 1, v is at plus b squared. So derivative becomes v squared and squared, so at plus b squared and squared, so to the power of 4, and u derivative is 0 minus u, it's 1, v derivative, but here also the same rule, chain rule arises, so something to power, you apply the same rule as it would be x squared, so it's what, something squared, derivative it's 2 times this, and something derivative, so it becomes minus 2 at plus b, and at plus b derivative, which is a, and let's check, you can see that it cancels, so it is cubed, and where is it, it's this, you can see we get that it's negative 2a over at. Yes, it's absolutely the same. Velocity after t seconds, so velocity as a function of time, it's this. And that's all for this question.